Good evening, guys, and welcome to interview preparation session by which is conducting by 360 GTMG. And in previous classes, in previous sessions we have seen some of the questions regarding Python, regarding some of them regarding choosers, and some of them were being Q&A type, right? So in today's class, we'll just prepare some of the questions which have been going across DS. Okay. So as of now, the first question of the day is explain the steps in making an decision tree, which means what are the steps to be followed to make a decision tree. So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, these were the steps to make an decision tree. Among them, the first step is take the entire data set as an input part. Okay, and you should take the entire data set as a single input, which means input part itself, and then you should calculate the entropy for the target variable as well as the predictor attributes. So you have to calculate entropy and predicted attributes as well. And the third step, you have to calculate your information gain of all the attributes. The fourth step is choose the attributes which have highest information gain at the root nodes, which means which can gather highest information gain. And the fifth step is repeat the same procedure, which means repeat the above four steps frequently on each and every branch until the decision node of each branch is finalized. Okay, these were the steps to be followed to make an decision tree. So as we jump into the next question, how can you avoid overfitting your model? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, Overfitting. Overfitting refers to a model that is only set for a very small amount of data and which directly ignores a bigger data, which means it directly takes to the considerations only the small amount of data, and it ignores the bigger data sets. Okay, there are three methods to avoid overfitting. There are first step. First method is keeping the model simple, which means if you take a simple data set, if you keep the model is very simple, then you can avoid this overfitting model, which means take fewer variables into accounts, thereby removing some of the noise in the training data. Use cross validation techniques such as k-folds cross validation. Okay, and the next step is use regularization techniques such as lasso rates, certain model parameters if they're likely to cause overfitting. Okay, these were the steps to be followed to avoid overfitting, guys. So as we jump into the next question, what are dimensionality reduction and its benefits? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, what are this dimensionality reduction and its benefits? This dimensionality reductions refers to the process of converting a data set with vast dimensions into data with fewer dimensions to convey similar information, which means the reduction helps in compressing the data and reduce the storage, but there will be no loss of any data. It also reduces the computation timer as fewer dimensions, which leads to some less computations. And it also improves the redundant features such as there is no point in storing a value in two different units like meters and inches. So as we jump into the next question, how should you maintain a deployed model? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah. As we look into this, how do you maintain this deployed model? The steps to maintain this deployed model are you have to monitor it, evaluate, and compare and rebuild it, which means monitor, which this monitoring of all models is needed to determine their performance accuracy. When you change something, you want to figure out how your changes are going to affect, which means this needs to be monitored to ensure it's going what it's supposed to do. Evaluate. Evaluation metrics of current model are calculated to determine if a new algorithm is needed, which means to if there are any updates needed to the data set, this evaluation metrics will just let us know. Compare. You have to compare this with an older or previous models by which you can choose or get the best one. Rebuild. The best performing model is rebuilt on the current state of data. So as we jump into the next question, how can you select K for K means? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this, we should use this elbow method to select K for K means. The idea of this elbow method is to return K means clustering on the data set where K is referred as number of clusters with sum of squares WSS. It is defined as sum of square distances between each member of cluster of its centroid. So this is how you do select K for K means. So as we jump into the next question, how can outlier values are treated? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Reducing number of rows and columns. Yeah, Kanchana, you're right. You're right. Regarding previous question, you're right. Now, as we look into this, how can an outlier can be treated? So you can drop outliers if it is a garbage value. Example, suppose you are taking an example as an height of an adult, which is in a sum of x feet. So this cannot be true as the height cannot be a string value, right? So in that case, outliers can be dropped. If the outliers have extreme values, they can be removed. For example, if all the data points are clustered between 0 to 100, but the point lies at 100, then we can remove that point. So if you cannot drop outliers, you can try a different model like data detection as outliers by linear models can be fit by non-linear models. Therefore, be sure you are choosing the correct model regarding those. Try normalizing the data. This way, the extreme data points are pulled to a similar range. You can use algorithms that are less effective by outliers. As an example, would be some random forest and all. So yeah, we can also treat these outliers. If there are any outliers, if there are any outliers, you can remove those outliers, right, by using winsorization, trimming those techniques. First of all, you have to check by using box plot whether each and every row has any outliers and all. If any row do have any outlier, then you have to use winsorization technique. Winsorization is the best method to remove those outliers. Or if in such cases it's a garbage value, you can just drop those values. As we jump into the next question, yeah, you are given a data set of cancer detection. You have built a classification model and achieved an accuracy of 96%. Why shouldn't you be happy with your model performance? What can you do about it? So if anyone knows, this is a question which has been asked in interviews. So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this, cancer detection. This cancer detection results is an imbalanced data. In an imbalanced data set, Accuracy shouldn't be based on the measures of performance. Okay, it is important to focus on the remaining 4%, which means represents the patients who were wrongly diagnosed. Early diagnosis is crucial when it comes under cancer detection and can greatly improve a patient's progress. Hence, to evaluate model performance, we should use sensitivity, true positive rate, specificity, true negative rate. This measures to determine the class-wise performance of the classifier. So as we jump into the next question, we want to predict the probability of death from heart diseases based on three important factors. Those are age, gender, and cholesterol levels. What is the most appropriate algorithm for these cases? And the options are logistic regressions, linear regression, k-means, and a priori rules. So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, the option is the most appropriate algorithm for such kind of cases, which means this disease based heart disease based regarding these three factors are logistic regressions. So as we jump into the next question, after studying the behavior of a population, you have identified four species individuals types that are valuable to your study. So you would like to find all users who are most similar to each individual type. Which algorithm is mostly preferred for this kind of studies? And the options are k-means clustering, linear regressions, association rules, and decision tree. If anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, and the option for this, as we are looking for some grouping data, grouping people together, right? So specifically, by four different similarities, it indicates the value of k. Therefore, k-means clustering is the most appropriate algorithm for this kind of studies. As we jump into the next question, what are feature vectors? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. As we look into this, what are these feature vectors? A feature vector is an n-dimensional vector of some numerical features which represents an object. So in machine learning, feature vectors are used to represent numeric or symbolic characters of an object in a mathematical way that which is easy to analyze. So as we jump into the next question, what is an logistic regression? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, logistic regression is also known as some logic model, and it's a technique which is used to forecast the binary outcomes for a linear combination of predictor variables. So as we jump into the next question, what are recommender systems? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah. As we look into this, what are these recommender systems? These recommender systems are a subclass of information. It basically it filtering systems that are meant to predict the preferences of ratings which are user you would give to a product. So as we jump into the next question, explain cross validation. So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. As we look into this cross validation process, this cross validation is a modal valuation technique, and for evaluating how these outcomes of a statistical analysis will generate to an independent dataset. It is mainly used in backgrounds where the object is to forecast and one wants to estimate how accurately a model will accomplish in practice, which means to know the accuracy of a dataset, how accurate is it, we use this cross validation technique. So as we jump into the next question, what is collaborative filtering? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer in a minute. Yeah, as we look into this, what is this collaborative filtering? Most recommender systems use this filtering process to find patterns and information by collaborating perspectives and numerous data sources and several agents. This is what collaborative filtering is. So as we jump into the next question, what were the drawbacks of a linear models? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this drawbacks of the linear models, the assumption of linearities of the errors, it cannot be used for count outcomes or binary outcomes, and there are overfitting problems that is which can't be solved. These were the few major drawbacks for this linear model. As we jump into the next question, how regularly must an algorithm be updated? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. As we look into this, how regularly must an algorithm be updated? You will want to update an algorithm when you want the model to evaluate as data streams through infrastructures. The underlying data sources is changing, and if there is a case of non-stationarity. So these were the things when you have to need to update the algorithm. So as we jump into the next question, why is resampling done? So if anyone knows the answer, can ping me in the chat box, and we'll discuss the answer within a minute. Yeah, as we look into this, resample is done in any of these cases when the estimation and accuracy of some sample statistics by using subsets of accessible data or drawing some randomly with a replacement from a set of data points and substituting labels on data points when performing some significant tests, validating models by using random subjects like bootstrapping, cross validation, and all. In such cases, we use this resampling. So as we jump into the next question, what is selection bias? So if anyone knows the answer, can ping me in the chat box, and we'll discuss the answer within a minute. Yeah, as we look into this, the selection bias, it is in general thing which is a problematic situation where the error arises is introduced due to some non-random population and those samples. So as we jump into the next thing, what are the types of biases that can occur during the sampling? So if anyone knows the answer, can ping me in the chat box, and we'll discuss the answer within a minute. So yeah, as we look into this, there are three. What are the types of biases? There are three types of biases: selection bias, undercoverage bias, and survivorship bias. So as you jump into the next question, what is survivorship bias? So if anyone knows the answer, can ping me in the chat box, and we'll discuss the answer within a minute. Yeah, as we look into this regarding the survivorship bias. So this survivorship bias is a logical error which directly focusing on aspects that support surviving a process and casually overlooking those that denote because of their lack of prominence. This can lead to wrong conclusions in numerous ways. So this is what a survivorship bias is. So that's it for the day, guys. Thanks for watching, and we'll meet you in the next session.